The purpose of this video is to demonstrate how to develop an amortization schedule for a loan. An amortization schedule is a table detailing each periodic payment on an amortized loan, typically a mortgage or car payment. Amortization refers to the process of paying off a debt, often from a loan or mortgage, over time through regular payments. While a portion of every payment is applied towards both the interest and the principal balance of the loan, the exact amount applied to interest and principal each time varies. An amortization schedule indicates the specific monetary amount put towards interest, as well as the specific amount put towards the principal balance with each payment. Most schedules also show the loan balance after each payment. As you will see, initially a large portion of each payment is devoted to interest. As the loan matures, a larger portion goes toward paying down the principal. Before we start the amortization table, let's revisit the equals payment function. Remember that the format is equals PMT with three variables separated by commas. The variables must be listed in the specific order, with the interest rate being listed first, the number of payments listed second, and the loan balance or principal listed third. In this example, the principal balance of the loan is $12,000, the interest rate is 12% per year, and the number of payments is 48, or for 4 years. The first step in the amortization schedule is to compute the monthly payment. We covered this in the last problem. As you will recall, the monthly payment can be computed using the payment function with the three variables separated by commas. In the next section of this handout, we will compute an amortization table. The handout will suggest specific cells to be used in helping you create the loan amortization table. These are suggestions only. It is much better if you understand the process and you can create the schedule on your own rather than referring to directions for specific cells. So let's take a look at creating an amortization table from scratch. The first step is to put in the required columns, which you will see on the screen. And since I have 48 payments, I'm going to enter 48 lines. I'm going to do this using the fill handle by putting in the first payment as 0 and the next one is 1, and then using the fill handle, dragging it down enough to have 48 payments. You don't have to worry about being specific because you can always add or subtract. So in this case, I have an extra payment. I'll just go in and delete it. The second step is to drop in the payment amount. On a fully amortized loan, the payments are of equal value each and every month. Since I already calculated the loan payment up here, I'm simply going to cell reference my payment number and then F4 that formula so that it won't change as I copy it. As you will recall, the F4 key will toggle between the absolute and relative cell address. So when I press F4, I make my formula static so that it won't change as I copy my cells down. I'm going to start off my amortization table by cell referencing the balance of the loan. And the interest calculation will be computed on a loan balance that continues to be reduced each month by every payment, Remember that interest is the principal here times the rate, which is static and not changing, times the time, which is 1/12. Since the 12% isn't changing, I'm going to once again hit my F4 key, and then I'll multiply by 1/12 because we're making monthly payments. That tells me that my interest on the first payment is $120. I might as well format all of these to be dollars and cents. And the principal is the difference between the fixed payment amount and the interest, which is the amount the bank charges for giving you the loan. On the first payment, since the bank is charging us $120 in interest, the principal value is equal to the payment minus the interest. The last step is to reduce the loan balance, not by the amount of the full payment, but only by the amount of the principal. So my formula will be the previous principal balance minus the principal just paid. If you do this problem properly, you should be able to take the entire, line and copy it all the way down to the 48th payment. The way that we'll know that we've done this correctly is my ending principal balance when I'm all done should be 0. And if I go down to the bottom, you'll notice that that is the case. In this problem, it's important not to use the equals round function. If you use the equals round function, you'll be off by probably about 12 cents. So you can see how quick and easy that loan amortization schedule was. Basically, we computed the formulas in this one line and copied it all the way to the bottom. If you continue to read the directions of the handout, they'll tell you that they want to know how much interest and principal would be paid each year. So I'm going to put in a column for total interest and a column for total principal. And I will calculate it at the end of every 12th month or year's time period. I'll put some color in here just so you can see it better. So the total interest for the first year would be the sum of all the interest payments from periods 1 to 12, and the total principal of the first year would be the sum of all the principal payments from month 1 through 12. I may have said year before, it's actually months. And you'll do that for all 4 years. Let me take a minute and put those items in so I can show you what happens at the end. So with our completed table, we can scroll down and see that the interest amounts go down as the loan matures, and the principal amount paid towards principal goes up, which causes our principal balance to go down each time. You can see at the end of the loan, here's the total interest cost, and of course the total principal balance has to exactly equal the starting amount of the loan. These tables will allow you to compute interest costs and potentially interest savings over the life of the loan. So in a nutshell, you can see that it only took us a few minutes to create an amortization schedule that the bank will normally charge approximately $35 to $50 for. It's important that you are able to create one of these for yourself. Not only that, this can help you a lot in planning, which we'll talk about in just a moment. I also want you to understand some other benefits from being able to create a loan amortization table. Once you have computed the payment using the equals payment function, and once you know how to amortize a loan, then we can put in different values to see how much quicker we can pay the loan off. I'll demonstrate this to you in a moment. Let's use our loan amortization schedule to talk about some what-if scenarios. Later on in your handout, you'll be asked some similar questions. For example, one such question would be, if you could afford to pay $400 per month, what would be the resulting cost savings in interest? Okay, to do that, let's take a look at the total interest paid so far, $3,168.29. I'm going to copy that at the top, $3,168.29. That was our interest savings under this first, or actually our interest cost under the first scenario. Let's change our payment now to be $400 and see if we can use the amortization schedule to see how much such a loan would cost us in interest. So I'm changing the payment amount to $400. Now I'm going and I'm looking at the new amortization schedule that should have updated all on its own. You'll see that the last payment will be after this 36th month because you see the loan going negative. So to see how much this loan would cost us, we're going to identify the line item, I'll make it a different color, where the loan goes negative. Let me change this to be blue. And obviously you're not going to pay the bank any more than you have to. So on the line where the payment went negative, I'm going to change the last principal payment to match the loan balance here, which is $335.12. After that, I'm going to cut out the rest of this loan because it would not be required. So I'm going to clear that amount to 0. So after I've cleared the contents of the remaining payments, since they would not be necessary, you can compare this interest cost of $2,338.47 with the previous interest cost and calculate the interest savings. So once again, my interest cost on this loan, let me go grab it, was $2,338.47, and we could calculate our interest savings as the difference between these two. With the old loan, the interest cost was $3,168.29. That was over 48 months. And when we changed our payment amount to $400, we found out that we could pay the loan off 1 year sooner in 36 months, which would result in interest savings of $829.82. You have the power of loans at your fingertips. In this respect, you could compare any types of loans and figure out whether the savings would be worth the effort taken to pay it back more quickly. I believe that along with the loan payment function that we learned in the previous exercise, the ability to be able to create and understand an amortization schedule will be of terrific value to you in your personal financial lives. So on this problem, once again, the handout will give you specific cells and specific amounts to put in the cells, but I much prefer that, similar to this problem, you understand the logic behind the formulas and that you are able to create a loan amortization schedule no matter what data is thrown your way. Of course, I have some cleanup work to do, but the purpose of this video was to demonstrate to you how easily it is to create a loan amortization schedule. Of course, I'm always available for help and for feedback, and I look forward to reading your updates by Sunday night.